When you think about AI, you probably picture something, well, digital, almost like a ghost in the machine, right? It feels weightless, instant, like pure magic happening on our screens. But behind all that magic is a massive, and I mean massive, physical reality that's changing our world in ways we hardly ever see. We've all done it. You type a prompt into an image generator, and boom, a masterpiece appears out of thin air. You ask it a super complex question, and you get a perfectly coherent answer, just like that. It's this incredibly seamless, powerful, and, well, clean experience. But that's only the very, very end of the story. So that's the big question, isn't it? Where does all of this incredible number crunching power actually come from? What are the real world gears, pipes, and wires that make all this digital wizardry possible? It's time to pull back the curtain. And the answer, it turns out, lies in these new kinds of buildings that are popping up all over the planet. The AI factory. And listen, that's not just some catchy metaphor. We are literally at the beginning of a whole new industrial revolution.
Yeah, and don't just take my word for it. This comes from NVIDIA's CEO, Jensen Huang, the guy whose company builds the chips that are the beating heart of this entire revolution. He's the one who called them AI factories. He sees these places as the modern-day version of those huge, sprawling factories that powered the entire 20th century. So what exactly is an AI data center? Well, it's not your standard server farm, that's for sure. Think of it more like a supercomputer facility on absolute steroids, one that's been specifically built for the crazy demands of AI. We're talking about a place packed with thousands and thousands of specialized processors, like GPUs, all wired together to chew through just mind-boggling amounts of data, all at the same time.
Okay, so building this new industrial base, it doesn't come cheap. And I'm not just talking about dollars and cents here. The hidden costs, the price we pay in energy and natural resources are absolutely staggering. Okay, just look at this comparison. It's wild. A standard server rack in a normal data center, it might pull about 5, maybe 10 kilowatts of power. But an AI server rack, we are talking 60 kilowatts or even more. That is a gigantic 6-fold leap in power density, and a jump like that has massive, massive consequences. All that power generates an incredible amount of heat. And to cool these new factories, you need water. A lot of water. This year alone, data centers in the US are set to use about 17 billion gallons. But look at the projection for 2028. It's expected to just explode to nearly 80 billion gallons per year. And of course, there's the money. The financial investment here is just astronomical. Citigroup is projecting that by 2030, global spending on these AI factories is going to hit $2.8 trillion. This is a complete gold rush, and it's fueling a construction boom like we've never seen before. Now, this explosive growth, you can probably see, creates a huge problem. This insatiable hunger for power and resources, it just isn't sustainable. So the entire industry is now in this desperate race to find a better way forward, a race for something people are calling green AI. And what green AI does is it completely reframes the goal. For years, the only thing that mattered was making AI models more and more accurate, more powerful. Green AI comes along and says, nope, that's not enough anymore. Efficiency, performance per watt, has to be treated as just as critical as raw accuracy. And this really gets to the heart of it all. We've already proven we can build these incredibly intelligent systems. The new and frankly much harder challenge is figuring out how to do it without totally breaking our energy grids and draining our natural resources. So the first and most immediate way forward is to just make our current tech radically more efficient. And this involves a really tight partnership between the physical chips and the code that runs on them. It's a strategy known as hardware and software co-design. So on the hardware side, the name of the game is specialization. Instead of using general-purpose processors, companies like NVIDIA and Google are designing custom AI chips. These things have special sections built right in. They're sometimes called tensor cores that are engineered to do one thing and one thing only, the very specific kind of math that powers AI. And because they're so specialized, they do it with incredible efficiency. But look, brilliant hardware is only half the battle. The software is just as critical. The whole goal here is to eliminate any wasted effort. For instance, some techniques will bundle a bunch of small computing jobs together so the processor isn't just constantly starting and stopping. Others use this really clever trick where they do parts of the math with a good enough level of precision that's way faster and more energy efficient, and they only save the super high precision stuff for when it's absolutely necessary.
And this just shows you how it all clicks together in the real world. You can really see the synergy. You start by picking the most efficient chip you can, like an NVIDIA H200. Then you run software that uses that good enough math, that automatic mixed precision, to squeeze out more than double the performance for the exact same cost. Every single piece, from the memory type to the chip itself, is optimized to be as efficient as possible.
And the impact of just the software alone is huge. We're not talking about small tweaks here. As you can see, a technique like mixed precision can literally double your performance per watt. And when you start combining several of these software tricks, you can get more than a threefold improvement in energy efficiency, all on the exact same piece of hardware. It's an amazing approach, but it's still about making our current engines run better.
But here's the thing. Making our current computers more efficient, while totally crucial, might only be delaying the inevitable problem. The really ambitious solution involves reinventing the computer from the ground up and taking inspiration from the most efficient information processor we know of, the human brain. I mean, these co-design strategies are incredibly important, but at the end of the day, they're just optimizations on a basic design that's about 75 years old. To make the next great leap in efficiency, we might have to throw that old design out the window altogether.
And this new approach has a name: neuromorphic computing. The fundamental idea is to build computer chips that are actually structured like the brain's own neural network. We're talking about creating artificial neurons and synapses that can process information in a massively parallel and therefore super energy efficient way. So here is the core problem with pretty much every computer we use today. For decades, we've kept the processor and the memory in separate places. This means data is constantly being shuffled back and forth, creating this massive data traffic jam that engineers call the von Neumann bottleneck. All that shuttling back and forth wastes a ton of time and energy. A neuromorphic chip, though, it solves this by putting the memory and the processing right next to each other, just like in your brain. The data doesn't have to travel, which could make these systems thousands of times more efficient.
So when you step back and look at the big picture, you see this fundamental tension that is going to define the next decade of AI. On one side, you have this absolutely insatiable demand for more powerful, more capable artificial intelligence, and on the other, you have the very real, very hard physical limits of our planet's energy, water, and raw materials. And that really leaves us with one final, crucial question to think about. Maybe the ultimate test of artificial intelligence won't be whether we can create a machine that thinks. Maybe the real challenge is whether we can build that machine in a way that our planet can actually support.